AMAL Mohammed, Assistant Professor, Department of Civil Engineering, Vedavyasa Institute of Technology. Today, as a part of Techtalk series, I am here to present a few ideas on the topic reactive powder concrete. Introduction. Reactive powder concrete is a ultra high strength and a high ductile composite material which is having a very advanced mechanical properties. The reactive powder concrete is a concrete. We can say that it is a concrete without coarse aggregate, but at the same time it contains cement, silica fume, sand, quartz powder, superplasticizer, steel fiber which is having a low water binder ratios. The compressive strength of reactive powder concrete ranges from 200 to 800 megapascal. So, how to get this ultra strength? The conventional concrete, it has already achieved the maximum compressive strength only in its existing form of microstructure. However, at such a level of strength, the coarse aggregate, it becomes the weakest link in the concrete. So, in order to increase the compressive strength of concrete even further, the only way is to remove the coarse aggregate. So, this philosophy has been employed in reactive powder concrete. The history of reactive powder concrete. The concept of reactive powder concrete was first developed by P. Richard and M. Cherry-Rezi in the early 1990s. The world's first reactive powder concrete structure, namely Sherbrooke Bridge in Canada, was erected in July 1997. The composition of reactive powder concrete. Mainly, the reactive powder concrete constitutes cement, sand, silica fume, superplasticizer, crushed quartz, water and steel fibers. Moving on to the main constituents of reactive powder concrete. The first one, cement. Cement is a binding material for the production of primary hydrates. Its particle size ranges from 1 micrometer to 100 micrometer. The optimum cement properties include tricalcium silicate of 60%, dicalcium silicate of 22%, tricalcium aluminate of 3.8%, tetracalcium aluminoferrate of 7.4%. Next one, sand. The coarse aggregate are replaced by fine sand. It gives strength to the concrete. The size of the sand ranges from 150 micrometer to 600 micrometer. Next one, quartz powder. The particle size of the quartz powder ranges from 5 micrometer to 25 micrometer. It must be in the crystalline form. Next one, silica fume. Silica fume is used for filling the voids and also to enhance the rheology and for the production of secondary hydrates. The particle size of silica fume ranges from 0.1 micrometer to 1 micrometer. Next one, steel fibers. Steel fibers have been added to improve the ductility. It should have a good aspect ratio and also it should be able to improve the ductility. The length of the steel fiber, it ranges from 13 mm to 25 mm. The steel fibers should be also straight. Next one, superplasticizer. The superplasticizers has been used to reduce the water-cement ratio and also to improve the workability. A copolymer of acrylic ester, a polynaphthalene of sulfonate, a polymelamine sulfonate are normally employed for the purpose as superplasticizer. The table shows the reactive powder composition by weight for RPC 200 and also for RPC 800. The components of reactive powder concrete with function parameters. So the first component, sand, it mainly gives strength to the aggregates. Cement is used as a binding material. And next one, the quartz powder. Quartz powder mainly maximize the reactivity during the heat treating procedure. Silica fume, it fills the voids. Steel fibers are used to improve the ductility. Superplasticizers are used as to reduce the water binding And moving on to the types of reactive powder concrete, the RPC family mainly includes two types of concrete, which is designated as RPC 200 and RPC 800. RPC 200, it has a compressive strength of 200 megapascal, and RPC 800, it has a compressive strength of 800 megapascal. The properties of reactive powder concrete. The properties include compressive strength, flexural strength, water absorption, water permeability, homogeneity, compactness, microstructure, and material ductility. Moving on to detail, compressive strength. The compressive strength of reactive powder concrete is mainly higher than the high performance concrete. High performance concrete is conventional concrete which is having high strength, high workability, and high chemical resistance. The maximum compressive strength of high performance concrete is 75 megapascal, whereas the compressive strength of reactive powder concrete, it ranges from 200 to 800 megapascal. Flexural strength. The plain RPC is found to possess marginally a higher flexural strength than high performance concrete. The increase of the flexural strength of RPC with the addition of steel fibers is higher than that of high performance concrete. The flexural strength at first cracking is also higher than the ultimate flexural strength of the normal concrete. Water absorption and permeability. The percentage of water absorption of RPC is very low compared to that of high performance concrete. This quality of the RPC is one among the desired properties of the nuclear waste contaminant materials. Incorporation of the fibers and use of heat curing, this marginally requires the increase in the water absorption. Also, the permeability of RPC is almost 7 times lower than that of high performance concrete. Compactness. The application of pressure before and during the setting period mainly impart compactness. Microstructure of the cement hydrate can be changed by applying heat treatment during the curing procedures. Material ductility. The material ductility can also be improved through the addition of short steel fibers. Moving on to the applications of the reactive powder concrete. Reactive powder concrete is mainly used in the nuclear waste contaminant structures due to its lower water absorption and also low permeability. Also, RPC is used for heavily loaded structures like bridges due to its ultra high strength and its durability. Also, this is used for marine structures due to its high chemical resistance. And moving on to the limitations of RPC, it is actually least costly components of the conventional concrete which are then eliminated by more expensive elements. The mineral component optimization alone, which results in a substantial increase in the cost over and above that of conventional concrete, that is around 5 to 10 times higher than that of HPC. RPC is still in the initial stage only, so long-term properties are not yet known. Also, applying the pressure to this mix and applying heat treatment in the field has got some of the technological difficulties, and also it increases the cost of the procedure. So, we can conclude that next to water, we have seen that concrete is the second most consumed substance on the earth. So there is a possible chance that the material might get extinct in the future. So RPC can be used so that it will allow the concrete industry to optimize this material use, generate economic benefits, and build structures that are strong and durable. By using the RPC optimization of materials, this can be done because of its high strength. So, since the dimension of the structural elements are reduced and hence less materials are used. Also, the reinforcement can be avoided in some cases only, and hence it can give some economic benefits. So this is about RPC. Thank you.